So 3Dponics is a creative and practical application of 3D printing. And we all know that 3D printing is huge and is going to be even bigger in the future. But there seems to be a bit of a disconnect, a little bit of uncertainty as to how this is actually going to be big. And one of the questions that we looked to answer was, well, how can we answer this question at the early stages of 3D printing? So before I get into answering that question, I'll just give you a little bit of a background on our company. So we started off as hobbyists. We bought our first 3D printer, an awesome MakerBot 2 in 2013, and just started messing around with it. We went to sites like Thingiverse and downloaded all sorts of STL files, spent hours learning that arduous 3D printing process. We had many deformed and failed prints, many hours of frustration, tons of filament, spools all over the place, and we scoured the forums for advice and help on how to do it. Out of all of that, though, came excitement and joy whenever we had something that actually turned out to be okay and we could make it out. We saw that in 3D printing, when we could hold a physical object in our hands that we spent hours designing or minutes downloading, there was something magical about that. And we grew, and I say we as a team, we grew in love with 3D printing technology itself. And for us, it opened an entire new world. We have a lot of interesting hobbies up in Canada, and one of them was flying quadcopters. And we would retrofit cameras to these drones, thermal imaging cameras, of course, because we wanted to see if our roofs were being well insulated during our cold winter months. And one of the things that we saw with this quadcopter was the gimbal, the device that actually allows you to monitor and move the camera, was non-existent on the actual controller itself. So with this newfound technology of 3D printing, we actually designed and printed a lever for the DJI Phantom quadcopter. A very small piece of plastic, about an inch in size, that we were able to place directly into the controller and give us full access to that particular controller. It was awesome. And we put it up on all the 3D printing file sharing sites like Thingiverse, etc. And we saw that all sorts of hobbyists that were using these quadcopters loved this part. They needed it for what they were using. So naturally, the kind of entrepreneur aspect of who we are came into place. So we took this 1-inch piece of plastic that took us a few hours to make and a few seconds to print out, or I should say a few seconds to design, a few hours to print out. We put it up on eBay, and it started giving us an awesome idea. We saw that in 1 month of having just this tiny piece of plastic, we made over $5,000. And for us, although $5,000 is not a lot, for what we actually did, it was huge. We saw that we were on the precipice of something that could potentially be big. We quickly turned this hobby that we had into a revenue-generating idea. So we quickly incorporated 3D Printer Labs as a company, and we took that one design, that 1-inch piece of plastic, and we turned it into an entire store, and we multiplied our sales exponentially. And so for us, we started seeing right away that in 3D printing, because it's so new, the market is also very new and uncharted territory. So we did whatever we could to expand on that and make it interesting and make it viable. So we put up a few little recipes to our success, and it's something that we applied to every new product that we place on our website. The first thing is that the components, the 3D printed components, needed to be practical. There's a lot of awesome things on Thingiverse that are just kind of toys and trinkets, nothing that you can actually physically use. And where we saw the money was coming in was through components that were actually practical, that would enhance or alter an existing product or component. We actually made all of our files custom. So you could customize the size, the width, the depth. Every component of our files were custom designed. In fact, we all have an open source background. We're all kind of ex-hackers, if you will. So we really believe that the power is in the people to design the files that they need and to make it as robust and as versatile as they need it to be. The other secret to our success was making and finding niche markets, niche interests, like quadcopters. There's a very, it seems very narrow, but within that particular market, there's a whole other world filled with people who are willing to spend lots of money to get the add-ons that they need. So we found that niche interests were crucial to our recipe of success. And naturally, going outside the box in terms of marketing. Guerrilla marketing has always been something that we believe is crucial in all of the businesses and that we've ever had as a team. Out of all of this, with 3D Printer Labs, from designing the quadcopter edition to selling it online and making money and starting to see this need and interest in 3D printed components and marketplaces for 3D printers, we were still left with the big question still. How is this going to impact the future? And we understood the answer to that question to be the future itself. So the kids in classrooms. So we know that, as a 30-something-year-old, that my knowledge of new technology is still, rather limited. Whereas kids these days, they're growing up into this technology, so their ability to grasp and run with it is going to be incredible. So what we saw was that classrooms and students needed to be equipped with something that would encourage them all. Another thing that we saw is that schools are going to be getting a lot of 3D printers. In Canada, it's becoming huge. And I know in the United States, it's also becoming really big as well. There's a big push for science and technology and 3D printers to become an integral part of the classroom. The one thing that teachers don't have is something practical to use the 3D printers for. So 3Dponics came into be as, again, part of all the recipes to our success in the past. 3Dponics is basically a vertical hydroponic system that you can grow fresh fruits, vegetables, and herbs year-round just by placing it in your window using 3D printed components, recyclable bottles, and reusable parts. It's really easy to make, really easy to print, and it's practical. And actually, more than being practical, it actually works. So we, again, living in Canada where it's winter 6 months out of the year, we decided to start growing tomatoes in our office window. And the results were actually pretty tasty, I must admit. And so what we saw is that we actually had something that could be used in schools. We saw that it incorporated science and technology, it incorporated 3D printing and design, and it also opened up windows and doors to all sorts of other facets, such as agriculture, eco-sustainability, etc., etc. Based on our experience with guerrilla marketing, although we're a bootstrap company, we decided to launch a fundraiser campaign, mainly as a means of promotion. We were ultimately successful in achieving our goal. We surpassed our goal. And some of the elements that we wanted to showcase and demonstrate and incorporate into 3Dponics was we wanted to launch a community-based website so that every person who has a 3Dponics system could, for example, upload pictures of their design, upload the different aspects and components that they've added into the system, and they could connect with other users who are doing the same thing. So essentially a community of people who are either 3D printing enthusiasts or urban growers and farmers, people who are all interested in this sort of niche interest to collaborate and join together in making their systems better. Again, that open source idea still being behind what 3Dponics is all about, is making the core system a lot better by having everyone involved. So with the funding, we helped to launch that community-based website. And the second component was something that we thought was really interesting, was having a farm automation software. So basically in hydroponics, which again, as a niche interest is really huge and really interesting, we saw that there was a big need to have something that could monitor and regulate all of the components necessary to make your plants grow healthy and strong. So for example, right now we're away from our office and we have all sorts of plants and stuff growing up there. But we have no way of knowing if our systems are working, if the nutrients are okay to our plants, if the pH levels are out of whack, or if, for example, our air pump or water pump has failed. So with this farm automation software, using very basic Arduino components and sensors, we actually receive notifications on our phone that indicate to us that, for example, the humidity levels need to be adjusted, or the pH levels need to be adjusted. And then with the automated software, we could adjust it remotely through the cloud and through the system, regulate the systems from afar. So the farm automation software is just a tip of the iceberg. Because when you put this type of idea into the hands of school children, and they're compelled to come up with an addition to it, the results are going to be incredible. And that brings us to our next component, where in schools, although they're getting all these 3D printers and they need something to do, something practical to use them for, we've developed and are implementing curriculums into schools in Canada and the United States. So it's an actual curriculum that's based around 3D printing, that's based around the vertical hydroponics, based around the software, based around all of the things in between that make the system work. Education is our passion, and we've been collaborating with educators in Canada, the US, and even Europe to help bring our system into schools and to help make it a part of ongoing the STEM components to education, science, technology, engineering, mathematics, as well as other outside-the-box ideas that are becoming increasingly popular, like agriculture, sustainability, and even entrepreneurship. Just to kind of give you an idea of some of the individual approaches to schools that we've taken, in Canada in one school, we've implemented a micro-entrepreneurship program within the 3Dponics system. So essentially we've sent out a goal for whoever can come up with the best addition for the software. Whoever wins will get X amount of money, and will help put their system onto our marketplace. Any percentage of sales that that are made through the sale of that system on our global online store available to anyone with access to a computer, the classroom or that group will get a percentage of that revenue stream. So there's all sorts of incentives to get kids thinking about how to become entrepreneurial in the 3D printing marketplace. Because we do believe that where it starts is where we all sat years ago. So having a practical use for 3D printers in school will allow for better budgets in technology. See, one of the things that we saw was, although teachers are really, really interested in the system, as soon as they hear what 3Dponics is all about, they jump on it like a fat kid on a Smartie. But the thing is, they don't have the budget. They have to either raise the funds themselves or dish it out themselves to get it in, and then figure out how to get reimbursed. But we think, and we know, that if the school boards see that there's an actual practical application to it, that they're going to want to invest into it. And where everybody benefits is this. So we know that there are certain 3D printer manufacturers, people who make the printers or make the filament. They know that schools could potentially be a big market. Think about how many schools, think about how many potential printers could be sitting inside those schools. What they don't have is a way to get into those schools. What we have is that way to get into schools. So what we become is essentially a middleman, if you will, to connect these manufacturers of 3D printers, of hydroponic grow mediums and nutrients and other software components, little bits, etc. We become a medium for these components to get connected and filtered into schools as part of a curriculum-based, regular revenue generating stream. So in 3Dponics, we believe that everything starts from something really small, from a seed to a tree, from a hobby to an enterprise, from a student to CEO, and from Earth to Mars. And I want to touch on that just a little bit. How many people here know about the Earth to Mars project, the Mars project itself? I think it's incredible what they're currently doing, having the 3D printers in Mars and being able to print these components and tools that they need on a regular basis. So we're connecting with that particular team to bring our idea of eco-sustainability and food production to another planet. What's really interesting is that we're not doing it. It's the students who are doing it. So they're the ones who are going to come up with how to make this work, how to deal with the lack of adequate gravity. So it becomes an actual fun project for them to be involved in. Our motto is, let's all grow together. We believe that everyone can be a part of this. Everyone who is interested in 3D printing technology can become a part of what we're essentially trying to do. And it's not so much just the 3D printed components or the 3Dponics system. It's not just a vertical hydroponic garden. It's the idea of empowering our children and the children of the future to become familiar and have access to these technologies in a practical and viable way. And that's what we believe everyone in this room can be a part of. When I walked around all of the booths, and it was a lot to take in, I saw how much awesome technology there is and how much the future is going to drastically change. I'm excited. I hope I live long enough to see a lot of it come to pass. And I think it's going to be even more exciting to see what students come up with for the future, what type of ideas they may have. And although our idea is very fundamental, we believe that the fruit of that labor will be exponential. So although we're based in Canada, we do have a satellite office here in San Francisco. I really do appreciate the time that you guys have given me to listen to our idea, listen to our vision for the future of empowering schools with this technology and the idea that everyone can be a part of doing something massive. So thank you very much. Appreciate it.